In this video, we are going to discuss uh, important aspects about cross-section study, which is also called survey study, which is also called prevalence study, and it's also called disease frequency study. It means that there are so many uh, names for the cross-sectional study that can be used, that are commonly used by different authors. And now we come to the definition of cross-sectional study, which is defined by Porta as it is a study that examines the relationship between diseases or other health-related characteristics and other variables of interest as they exist in a defined population at one particular point. And however, other authors like Alan Silman and Gary J. Emphasize it as the method to determine the point or period prevalence of a disease or attribute. They are commonly descriptive, usually in the form of survey, which when we aim to study a variable among the study population. For example, prevalence of tuberculosis among school children in certain geographical area, in certain city or village. And if the cross-section studies are designed to generate information about whether there is an association and between the prevalence and other study variables, then, for example, association between prevalence of TB stigma among and defaulting rate among TB patients, it may be described as analytical. And this type of descriptive study categories include common diseases surveys and, for example, non-communicable disease surveys, surveys about health problems such as female genital cutting, gender-based violence, among women population in a certain area. The disease design, the cross-section design may be also used in health system research, for example, to describe the prevalence by certain characteristics, pattern of health service utilization and compliance, or in opinion surveys. It's a common procedure used in family planning, for example, to examine the knowledge, attitude, and practice of pregnant, of married women, reproductive age about family planning, or knowledge, attitude, and practice of pregnant women about the tetanus toxoid, for example, or other important aspects. In this slide, we can see that the design usually have a defined population, which is the study population or the parent population, and then we gather data on exposure and the disease, exposure and the outcome, for example, and then we can come up with the final results that we have a group of people who are exposed and have the disease, another group who are exposed and do not have the disease, another group who were not exposed and have the disease, and another fourth group who were not exposed and they did not have the disease. We can use the 2x2 tables to test for the association in cross-section study design. As we can see that we have a 2x2 table showing the disease and showing the exposure status of the study population, and then we can go to estimate for the prevalence rate, for example, of disease among the population, and we can test for odds also among of disease among the study population, and we can test for odds ratio to test for association between exposure and disease. Using 2x2 table in the previous slide, you can compare the prevalence rate of the disease among, for example, exposed person A divided by A plus B with the prevalence rate among non-exposed, which is C over C plus D. And also we can compare the prevalence rate of exposure among persons with the disease A over A plus C, with the prevalence rate of exposure among persons without the disease, P over B plus D. We can use the odds ratio to test the strength of to assess the strength of association between the exposure and disease using the formula A by D divided by B, or divided by B multiplied by C. We can use any of the software which are available for calculation of the odds ratio. We can use, for example, Easy Calculation or medicalcard.org or other softwares that are available in the addresses are shown in this slide. Generally, an oscillation is suggested by an odds ratio larger or smaller than 1. The further the odds ratio is from 1, the stronger the apparent association. Statistical significance can be tested using p-values for the chi-square test, or, for example, other tests that are small. In other words, less than 0.05, the critical value is often used. Fisher exact test with a small p-value or confidence limits for the odds ratio that do not include 1. And if the 95% confidence interval does not contain the value 1, the p-value is strictly less than 0.05. Now we have an example here that we can go over it and see how we can apply the 2 by 2 table and apply the how to use the test. A questionnaire was sent to 500 university students aged over 18 and age over 18 years of age, and selected randomly from one of the university. They were asked about whether they ever smoke, current smoking habits, type of smoking, frequency of smoking. In addition, information were collected on the general health smoking habits among the parents and other family members. That is the main aim of the study. The investigator aimed to estimate the prevalence of smoking among university students and whether there was any relationship between smoking and the determinants about which information were collected, as we see, for example, smoking among parents and smoking among other family members. And here we can see how to test the association between history of smoking versus smoking among parents. And we have the 2 by 2 table, and then we can see the application. For example, the prevalence rate of smoking among students whom parents were smoking is 140, or divided by 200 multiplied by 200 multiplied by 100, which is 70%. And the prevalence rate of smoking among students whom parents were not smoking is 80 over 300 multiplied by 100, and this is 26.7%. Also, smoking among students whom parents were smoking is 140 over 60, and this is equal to 2.3. And also, smoking among students whom parents were not smoking is 80 divided by 220, which is 0.36. Odds ratio, we can calculate it 140 multiplied by 222 divided by 60 multiplied by 80, which is equal to 6.42. The confidence interval is 4.3177 to 9.5359, and the chi-square test using the appropriate software is 91.45. And this will show us how to calculate or to estimate the association between the variables in the cross-sectional studies. Now we come to some examples of surveys or cross-section surveys that were previously carried in Sudan. For example, Demographical Survey, DHS, in 1992, and Safe Motherhood Survey, SMS, 1999, Multiple Indicator Cluster Survey, MIX, in year 2000, and Sudan Household Survey, SHS, in years 2006 and 2010, and Integrated Bio-Behavioral HIV Surveillance Survey, IBBS, in year 2012, Multiple Indicator Cluster Survey in years 2014. The advantages of the cross-section study is that cheaper, there is no follow-up compared to other types, for example, cohort study design, and as well as these studies are visible and relatively short time saving. Within a short period, you can carry the cross-section study, and useful to estimate the prevalence rate of a disease, and appropriate for studying the frequency of occurrence of diseases and health-related events and chronic long-standing diseases having high prevalence and low incidence, useful for establishing associations rather than causality, in the other sense that we can test for association between the variables rather than finding etiological association between, for example, dependent and independent variable. Can provide useful information if conducted repeatedly for the health disease, for example, surveillance of the cases at the community level, and provision of information about disease load at the community level is another advantage. Where the generated data can be used for priority setting, for formulation of strategic plans, for formulation of annual plans, for information-based interventions, and as well as the genetic information can be used for monitoring and evaluation purposes at different levels of the healthcare delivery system. The disadvantages of the cross-section study, the data on temporality are not reported. Thus, we cannot establish relationship between the exposure and the outcome. For example, the exposure to certain disease agent and the disease, as we are not sure from the collected data which occurs first. As well, another disadvantage is that we cannot measure the incidence rate of a disease, as we need newly diagnosed cases to measure it. Recall bias is another disadvantage. Confounding variables may not be equally distributed, and usually the cross-section studies are inappropriate for studying rare diseases or diseases with high fatality, as we cannot find cases to study. Thank you very much.